Welcome to our Form 2 Agriculture Digital Content. Agriculture is an important subject in our day-to-day life. In Form 1, you are introduced to both crop and livestock practices. In Form 2, you will continue broadening the content scope using the following topics: inorganic fertilizers, planting crop plants, nursery practices, field practices, vegetables production, introduction to livestock health, livestock parasites, and livestock nutrition. You'll also have the opportunity to practice some hands-on skills in answering examination questions as a preparation for the subject evaluation. Welcome and enjoy all the activities in Form 2 Agriculture Digital Content. Welcome to our Form 2 Agriculture Digital Content. Agriculture is an important subject in our day-to-day life. In Form 1, you are introduced to both crop and livestock practices. In Form 2, you will continue broadening the content scope using the following topics: inorganic fertilizers, planting crop plants, nursery practices, field practices, vegetables production, introduction to livestock health, soil fertility 2 or inorganic fertilizers. Introduction. Soil fertility is the ability of the soil to supply all the essential elements to plants in their correct proportions. In this topic, we are going to cover essential elements, inorganic fertilizers, soil sampling, and soil testing. Objectives. By the end of this topic, you should be able to list the essential elements, classify the essential elements, state the role of each macronutrient, describe the deficiency symptoms of the macronutrients, identify and classify fertilizers, describe the properties of various fertilizers, describe soil sampling and testing procedures, use appropriate methods of fertilizer application, calculate fertilizer application rates, and explain how soil acidity and alkalinity affect crop production. There are various ways through which soil loses fertility. Let us remind ourselves some of these ways: leaching, soil erosion, monocropping, continuous cropping, and burning. Soil fertility may be maintained through methods such as manuring, control of soil erosion, mulching, weed control, irrigation, drainage, crop rotation, and soil pH control. Suggested practical activities in inorganic fertilizer. Learn us to plant 12 cabbages seeds in selected containers. After 2 weeks of growing, seedlings are selected for the following treatments. To the first 2 seedlings, supply all the nutrients except nitrogen. To the second 2 seedling, supply all the nutrients except phosphorus. To the next 2 seedling, supply all the nutrients except potassium. To all other seedlings, supply all the nutrients required. Observe the growth habits of the crops for the next 2 weeks as shown below. Fill the table below by measuring the length, width, and height of the stems on different days after the above treatments. Below is a list of deficiency symptoms in crops. Drag and drop each of macronutrients to the appropriate symptom. State whether each of the following statements are true or false by clicking the correct button. Foliar fertilizers are applied using side dressing method of fertilizer. Foliar fertilizers have scorching effect on plants. Foliar fertilizers exist in solution form. Match each of the following fertilizers to their respective properties by typing the correct fertilizer to the respective box. Soil fertility is the ability of the soil to supply all the essential elements to plants in their correct proportions. Essential elements are nutrients required by plants for normal plant growth. Macronutrients are nutrients required by plants in large quantities. Micronutrients are nutrients required by plants in small quantities. Soil sampling is the taking of some soil from a piece of land which is a representative of the whole land. Soil testing is the process of analyzing the soil samples. Essential elements. Essential elements are nutrients needed by plants for normal plant growth. Lost nutrients can be replaced through application of fertilizers. Essential elements are in 2 categories, namely macronutrients and micronutrients. Macronutrients. The macronutrients are required by plants in large quantities. Macronutrients include nitrogen, phosphorus, potassium, magnesium, sulfur, calcium, hydrogen, oxygen, and carbon. Micronutrients. The micronutrients are required by plants in relatively small quantities. Micronutrients include molybdenum, chlorine, manganese, zinc, copper, iron, and boron. Roles of nitrogen in crops: helps in protein formation, forms part of chlorophyll molecule, encourages vegetative growth, increases size of cereal grain, and regulates the availability of phosphorus and potassium to plants. Take note of the yellow leaves in maize as a result of leaf chlorosis due to nitrogen deficiency. Role of phosphorus in crops: formation and establishment of roots, helps in metabolic processes, helps in cell division, quickens ripening of fruits, helps in flowering, fruit formation and seed formation, and strengthens plant skeleton structure. Observe the purple color of leaves on kale crop showing phosphorus deficiency. Role of potassium in crops: helps in carbohydrate formation and translocation, assists in uptake of nitrates from the soil, imparts resistance to crops against diseases, strengthens straws of cereals, helps in development and formation of chlorophyll, helps in neutralization of organic acids, helps in plant metabolism, and balances the effects of nitrogen and phosphorus. Observe keenly the leaf curling and yellowing of leaf on the cabbage crop. Roles of magnesium in crops: forms part of chlorophyll, aids carbohydrate metabolism, helps in oil formation on some legumes, promotes nitrogen fixation in legumes. Deficiency symptoms of magnesium in oranges: observe the purple, orange and red patches of color on the leaves. Roles of sulfur in crops: helps in formation of plant proteins, helps in formation of plant hormones, helps in formation and activation of certain enzymes, and influences certain physiological processes in plants. Few nodules are observed on the roots when beans lack adequate sulfur. Roles of calcium in crop production: strengthens plant cell walls, helps in protein synthesis, helps in cell division, raises soil pH of acidic soils, promotes formation of soil aggregates, and makes phosphorus and potassium more readily available in the soil. Observe the water-soaked blossom ends of fruits due to calcium deficiency in young fruits. Macronutrients exist in ionic forms when dissolved in water. Observe nitrates, potassium, magnesium, and calcium being absorbed in ionic form. Observe copper, iron, manganese, and zinc absorbed by cabbage in their ionic form. Classification of inorganic fertilizers. Inorganic fertilizers can be classified according to main fertilizer element content, mode of application, time of application, and effects of soil pH. Nitrogenous fertilizer contain nitrogen as the only primary macronutrient. Examples include calcium ammonium nitrate or CAN, ammonium sulfate nitrate, and urea. Characteristics of nitrogenous fertilizers are highly soluble and hence easily leached, are highly volatile when exposed to high temperature, short residual effect, have scorching effect on plants, highly corrosive, and they are hygroscopic. Observe keenly the scorched leaves of the tomato plant. Phosphate fertilizers contain phosphorus as the only primary macronutrient. Characteristics of phosphate fertilizers are sparingly soluble in water, have high residual effect. Observe residues of DSP remaining in the soil after harvesting, are not liable to leaching. Observe the SSP granules remaining despite presence of infiltration water, and have slight scorching effect and hence must be mixed with the soil after application. Examples of phosphate fertilizers are SSP, DSP, basic slag, soda phosphate, and steamed bone meal. Farmers normally have varieties of phosphatic fertilizers to choose from as sources of phosphorus. Potassic fertilizers contain potassium as the only primary macronutrient, have moderate scorching effect, and have moderate solubility. Examples of potassic fertilizers: potassium chloride fertilizer and potassium sulfate. Compound fertilizers contain two or more primary macronutrients. Examples include diammonium phosphate, monoammonium phosphate, nitrophos, and NPK. Farmers have a variety of compound fertilizers available for crop production. Foliar feed fertilizer are fertilizers in solution form and sprayed onto the foliage leaves. Examples include Greenzeet and Bayfolan. Greenzeet contains nitrogen, phosphorus, potassium, iron, zinc, manganese, molybdenum, copper, nickel, and cobalt. Foliar fertilizers contains nitrogen, potassium, phosphorus. It also contains vitamin B, growth hormones, and all micronutrients.
Another field management practice is spraying of the crops with foliar feeds, fungicides, and insecticides. But today I'm going to spray the crops with a foliar feed. The foliar feed is necessary for fruit and flower development. So when applying the foliar feeds, you're supposed to follow the manufacturer's instruction. Before spraying the crops with the foliar feed, you're supposed to make sure that you wear protective dressing. Like for example, you must wear gumboots. There's the gas mask, there's the apron, and you are supposed to wear gloves and a cape. So, following the manufacturer's instruction, you mix the water with the foliar feed at the required rate. For this one, 20 grams is adequate for water of about 15 centimeters cube. The sieve is used to filter foreign particles that may block the nozzle.
Methods of fertilizer application. Broadcasting application of fertilizer by scattering. It can be done by hand or mechanically by spreaders. Observe the broadcasting of CAN fertilizer on a pasture of grass. Placement method involves fertilizer application within planting holes, furrows, or drills. Side dressing is the placement of nitrogenous fertilizer at the side of the crop being top dressed. Application can be in form of a band, that is, along the crop rows, or in form of a ring around the crop. Foliar spraying involves application of specially formulated fertilizer solution onto the foliage of the crop.
I'm going to do another method of fertilizer application in the field, the top dressing, and this is done in two ways. But first, you're supposed to wear protective clothing. That is where I want to put on gloves. You put on gloves because when you are doing top dressing, you are using nitrogenous fertilizers. This is urea. You use gloves because nitrogenous fertilizers have a scorching effect. So it is better to use gloves to prevent any accidents. So there are two methods of doing top dressing. The first one is side placement. So you take your fertilizer and just side dressing, you apply the fertilizer at one side of the plant. And there is also ring application, of which you apply the fertilizer around the plant.
Importance of soil sampling. Soil sampling is recommended since testing all the soil from the whole piece of land is practically impossible. Soil sampling is done using traverse or zigzag method. In traverse method, 4 corners of the field are marked and sampling locations arranged along diagonal line. In zigzag method, a farmer moves and makes left to right sampling locations in random movements. Precautions to be avoided during soil sampling. Avoid any contamination with the soil. Avoid mixing topsoil and subsoil. and avoid sampling soil from unusual areas such as the anthills and dead furrows. Areas to be avoided when carrying out sampling. Swampy areas tend to have more nutrient content than usual. Terrace stand tends to have higher nutrient content than usual. Dead furrow tends to have less nutrient content than usual. Manure heap tends to have less nutrient content than usual. Procedure to be followed when carrying out soil sampling. Clear vegetation from sampling spots, for example, through slashing. Make vertical cut 5 cm deep in pasture land and 15 cm on cropland. Take a slice from the vertical cut. Repeat the above steps each of the 20 sampling spots. Dry the sampled soil under shade. Break up the soil clods into fine particles. Thoroughly mix the soil samples. Put soil sample in a clean container. Label the container.
In today's session, we shall be doing a practical on soil sampling. What do you understand by the term soil sampling? Yes?
Soil sampling is the process of taking a small portion of soil from the field to be a representative of the whole field in the laboratory for testing.
Very good. In soil sampling, we have to be very careful. We must always ensure that the sample we collect is a true representative of the fertility and the condition of our field. We must avoid collecting samples near the fences. The area near the fences has accumulation of organic matter which can increase the soil fertility. Collecting a sample from the fences may mislead during testing that soil is fertile in a given field. Number 2, avoid areas near compost heaps. Areas where there have been some compost heaps definitely will have high soil fertility. Taking a sample from such an area will mislead about the fertility of the entire field. Avoid such dead furrows. There could be accumulation of fertile alluvial soil. Fertile alluvial soil will definitely give us misleading information about the fertility of the entire field. Trees. Avoid trees. Areas under the trees also have high accumulation of organic matter. And picking a sample from there will actually mislead us about the fertility of the entire field. Always ensure when you are doing a sampling, you start off 6 meters away from the fence and place your initial peg at that point. During soil sampling, 2 methods are used. First, the traverse method. You can see the 2 diagonal setup of our field, or the zigzag method. We shall start our soil sampling by performing the traverse method. In traverse method, usually we identify the 4 corners of our field and we make diagonal lines in our field. We shall then collect samples along each diagonal line of our field. We shall start by identifying the specific point where we shall collect our initial soil sample. This will be the first point where we shall collect our initial soil sample. During soil sample collection, we usually dig up to 5 centimeters for grass crops, but 15 to 25 centimeters for food crops. We have to initially remove the top soil, the humus layer, and then we shall collect our soil from the part of the subsoil. Has removed the topsoil. Now we shall collect soil from this point. Dig deeper into this point. Our garden trowel is 25 centimeters long, and the hole where we shall collect our initial sample is 25 centimeters deep. We shall collect our initial sample from this point and this depth, and we shall put it into our bag. That is our initial sample. We shall now alternate to the next point of our sample collection. James, remove the top humic soil at this point. Good. Now dig up to 25 centimeters into the soil. Good. This is the second point where we shall collect our soil sample. Managed to get 6 bags of our soil samples. We shall now pour all our soil samples on this white background mat and mix thoroughly. We shall mix thoroughly to ensure homogeneity, which is important for the representative sample. All the samples have to be put on the mat. We shall very thoroughly mix our sample, ensuring that the contents of each bag mix with the content of all the other bags. This is very important during soil sampling. A sub-sample, also called the composite sample. This is the sample that we shall be sending to the lab. We shall pack it nicely in our envelope, and on the envelope we shall Label. 1. The name of our farm. Our farm is Jiri School Farm. Jiri School Farm. Our address is 555 Vika. The number of our lot is LR Kenyona 1001. The other information that we are supposed to have on our envelope is the date of soil sampling. Today is 14th of September 2009. That information must be clearly visible and legible. Our soil sample will now be addressed to the relevant laboratory. And on the other side of our envelope, we shall address our soil sample to the National Soil Testing Laboratories, Box 1000, Nairobi. We shall clearly ensure it's fully legible.
The process of soil testing involves the following steps: registration, storage, preparation, analysis, and report writing. Soil testing involves analysis of the soil to determine the cause of low yield, estimate the supply of available nutrients, indicate the soil pH, and indicate how much lime or fertilizer to be added into the soil. Note the increase in acidity as the arrow moves towards 1 and increase in alkalinity as the arrow moves towards 14. Importance of soil pH. Influences the availability of plant nutrients, influences activity of microorganisms in the soil, influences the balance of various microorganisms in the soil, influence the occurrence and virulence of soil pests and pathogens, and affects the growth and distribution of crops.
We shall now carry out our practical on testing for soil pH. The first step in carrying out our experiment will involve getting a sample of our soil onto a clean part of the white porcelain plate. The second step will involve pouring 1 to 2 cubic centimeters of our universal indicator solution. We shall add 2 cubic centimeters of the indicator solution. The third step requires that we drain